In this lesson, we're going to continue looking at quadratic equations. And as a reminder, for a quadratic equation in our general form, we'll have ax squared plus bx plus c equals 0. Right, so that's our general form for a quadratic. The highest exponent is 2, so called a second degree equation. And previously we had looked at solving quadratic equations using factoring, and so we looked at factoring, and then we also looked at the square root property. Okay. So now we're going to look at a couple more, because what if, say, factoring under the square root property, what if those don't work for us? So we'll need a couple other ways to be able to try and solve quadratic equations. So the next topic we're going to look at is called completing the square. And in a nutshell, what completing the square does for us is it allows us to turn a difficult quadratic equation into one that can be solved using the square root property, which, remember, is the square root property. That's where we have, if we have something in the form u squared equals d, then u is equal to plus or minus the square root of d. All right, and we know how to solve ones like that, like where we had, say, x plus 3 squared equal to 16. All right, so we have it set up in the form. We have our algebraic expression, squared equal to a constant. So we can take the square root of both sides. So then we end up with x plus 3. And then don't forget the plus or minus, square root of 16. And then, of course, we could solve it from there if we needed to. But most quadratics don't start in this form. And that's where completing the square comes in, because this x plus 3, that's a perfect square. But again, because most don't conveniently start out like that, we have the ability to make the perfect square. That's what completing the square will allow us to do, is turn our quadratic equation into a perfect square that we can solve. But let's take a look at the wordage behind this before we do an example. So to make x squared plus bx, to make that a perfect square, what we do is we add b over 2, and then we square that. We add that to here. All right, because there's our b, whatever b is, divided by 2, and then square that answer, and that gets added. And then that will give us a perfect square. So once we take, if we're given some x squared plus bx, and then we complete the square, so we take whatever b is, divide by 2, and we square that. When we add it to that, then that becomes a perfect square. So then this right here will become our perfect square that we can much more readily solve from there. So that's what completing the square allows us to do, figure out what we're adding on here, and then that becomes a perfect square then. Well, let's take a look at an example so we can see this more clearly. So if we were given x squared plus 8x, all right, so what we want to do is we just want to figure out what the constant is that we are adding that will give us a perfect square. That's all we're doing for this. All right. So we know that's our A, this is our B. So what we said for completing the square is we take B over 2 and then we square that. So in this case we have our B is 8. So 8 divided by 2 square, so 8 divided by 2 is 4. And we know 4 squared is 16. And then that's what we add on here. So now we are plus 16. And then that will give us, we'll rewrite it down here, so we have x squared plus 8x plus 16. So we determine that's our constant to add after we completed the square. And now this gives us a perfect square. We end up with x plus b over 2, which again, we said that was 8 divided by 2. That's 4, and squared. So we have here a perfect square, which is just what we intended to do with completing the square. And we can always check if we take x plus 4 times x plus 4, we do indeed. Of course, this is what we come out to. Let's try one more. Again, we're figuring out just what constant we're going to add. So if we have for this one x squared minus 14x, all right, so we know this is our b. Our b is negative 14. All right, so be careful with that. So completing the square, so we take b over 2, we square it, so we have b is negative 14 divided by 2. So negative 14 divided by 2, that's negative 7. And when we square that, negative 7 times negative 7 come out to a positive 49. So that is what gets added on then. That is our constant that gets added. X squared minus 14x plus 49. And that equals then x plus, and then we have b divided by 2, negative 14 divided by 2 is negative 7. So plus negative 7, so that would actually just be minus 7 squared. And that is a perfect square. All right, and x minus 7 squared will give us that. All right, so now let's move on to, now that we know how to determine what constant to add on by completing the square, let's do an example where we actually go about and solve for x. All right, so we're going to solve the quadratic equation using completing the square. So let's do x squared plus 18x plus 58 equals 0. All right. So we look at this first glance. mean, if I'm looking at this, first thing I think is, okay, maybe can I factor it? I mean, let's see, if we had 58, so be looking for factors of 58 that add to 18. Well, we have 1 times 58, and then we have 2 times 29. But the problem is that's it. And neither of those get us anywhere close to adding up to be 18. So factoring is not going to work. And then we're not in a position to be doing using the square root property. So let's employ now, let's do completing the square. So the first thing we need to do is we need to subtract this 58 over. Okay? That's what we want to do first, because we're going to need it remember, we're going to need it in this form. All right, so let's subtract the 58 over. So we have x squared plus 18x. And then by completing the square, we're going to figure out what this is. Equals, now we have negative 58 over here. Right, and now for completing the square, we take b over 2 squared, and in this case, our b is the 18. So we have 18 divided by 2 squared, which gives us 9 squared, which is 81. Okay, and now we've completed the square, so that is what gets tacked on here, is 81. But a key point here, do not forget, when we do that, what we do to the left side, we also have to do to the right side. So we added 81 on the left, but we also need to add 81 on the right. So do not forget that. After you complete the square, whatever you added, subtracted here, you need to do the same to the right side as well. So we end up with x squared plus 18x plus 81 equals, and then negative 58 plus 81 will get us positive 23. Okay. And again, here we have, by virtue of completing the square, we made ourselves a perfect square over here on the left side, which comes out to, I mean, this we could factor. Otherwise, if you remember the formula on the right side, we end up with x plus b over 2 squared, whichever way you want to go about it. So we end up with our perfect square is x plus b is 18 divided by 2 is 9, and then squared equal to 23. So now we're just expanding on what we were just doing. So now we actually have it equal to something, so we can actually solve for what 9 is. So, I just want you to see how we got to this point. We started off with our equation. We couldn't factor it. We couldn't do the square root property yet. So we subtracted the 58 over. We got it into this form, and we completed the square. And what we did to the left, we had to do to the right. So now we have a perfect square on the left side, x plus 9 squared, equal to 23. And now look what we can do. We have an algebraic expression squared. So now we can apply the square root property. Just what we said just what we said earlier in a nutshell. Completing the square allows us to take something that's a little bit more difficult to work with, and it allows us to make it into something easier that we can apply the square root property to. So now we're here, so we can just take the square root of both sides. So we end up with x plus 9 equal to, don't forget your plus minus, square root of 23. And I'll leave it under the square root. Instead of putting it in as a decimal, we'll leave it like that. And then to solve for x, we subtract the 9. And we'll throw the 9 out front. So x equals negative 9 plus or minus the square root of 23. And that is our final answer. So again, two solutions, negative 9 plus square root of 23 and negative 9 minus the square root of 23. But that is our final answer. That is seeing in a full example how we can go from a quadratic equation that's not as easy to work with. We can't just factor it. We can't go right to the square root property. So we complete the square, we get it into something that we can work with, and then we apply what we already learned with the square root property. Let's try another example. I have 3x squared minus 12x plus 6 equal to 0. Now for this one, I switched it up a bit. So we no longer have just 1 as our leading coefficient. We have 3 now. And when completing the square, we need to make sure that the coefficient of x squared is 1. If not, we need to factor out this coefficient. So that's what we need to do first. All right, if this leading coefficient with the x squared, if that is not a 1, then we're going to need to factor that out before we start with completing the square. So we factor out the 3, then we're left with x squared. And actually, I should say, first things first, sorry. Let's get that like we did with the first one. Get the 6 over first, because remember, we need it in the for completing the square, the x squared plus bx form. So sorry, move the 6 over first. So 3x squared minus 12x equals negative 6. Okay. Now, let's factor out that 3. Because that way we didn't, go factoring the 3 out of the 6. Get that moved over first. Get it in this form first. All right. So now, again, we have that 3 as the coefficient with the x squared. So let's factor that out. So we end up with, inside we have x squared minus 4x equal to negative 6. Okay, and now that we are at this step here, now we can complete the square on just what's inside the parentheses. So don't worry about the 3 right now. So again, we have b over 2 squared. So in this case, we have negative 4 over 2 squared. So that's negative 2 squared, which comes out to positive 4. So we still have this 3 here, but we're not worried about that at the moment. All right, we're just completing the square on what's in the parentheses. So just like we did before, x squared minus 4x. So now we determine 4. That is what is getting added on here. Okay. And that equals -6. And then here's another point where we have to be careful. So remember we said that what we have to do to the left, we have to do to the right. But here, we need to account for, we still have this 3 out front. So it's not just 4, we're actually taking 3 times 4. All right, because we still have to account for the fact that we have that 3 out front. So we're actually adding 12 to the right side. All right, just like if we were to distribute this, we have 12 on the left side, so we need to add 12 on the right side as well. What we do to the left, we do the same to the right. So we'd actually have, and this is our, this of course, this is our perfect square. So we can simplify that. Okay. Alright, so we'll get that simplified. So we have 3, and then again, if you want to factor it or just remember from the formula. So we end up with our perfect square is x plus, it would be plus -2, so plus a -2 would just be -2 squared. And this is equal to, so now here we have -6 plus 12. So now we're at a +6. So 3 times x minus 2 squared equals 6. So now we can, kind of like we had an example like this before when we were doing the square root property, don't go taking the square root now, get that 3 out of there first, simplify it, get that 3 out of there. So if we divide by 3, then we're left with x minus 2 squared equals 2. And now we can apply, we are in perfect shape to apply the square root property now. So we take the square root of both sides. So we end up with x minus 2 equals plus minus square root of 2. And then if we add the 2, we get x equals plus or minus the square root of is our answer. So let's look at where we came from here. So we started off up here, subtracted the 6, we got it in this form, the x squared plus bx, so we could begin to complete the square. Move the 6 over, and then because our coefficient tied to the x squared was not 1, we had to factor that 3 out. So now we were completing the square just on what's inside the parentheses. And when we did that, complete the square over here, the constant that we were adding on, we determined to be 4. So we added the 4 on here. And then what we do to the left, we do to the right. But then we had to remember that, if we distributed this, it's actually 12. So we had to add 12 to the right side to make it even. And then what's inside our parentheses, that perfect square is x minus 2 squared. And then can't forget about the 3 is still there. And then we divided out the 3, started working towards being able to to apply the square root property, square root of both sides. So you can see where completing the square is helpful for something that's more difficult. It allows us to simplify it and put it into the square root property. All right, and for this next method for solving quadratic equations, it's one you may very well be familiar with, or at least that you've heard of. So this will be now the fourth one that we've looked at. So this will be the quadratic formula. Which simply states that the solutions of a quadratic equation in general form, ax squared plus bx plus c equals 0. The solutions of a quadratic in general form, where a is not 0, are given by the quadratic formula. That's all it's telling us. If we got something in this form, we can apply the quadratic formula and figure out our solutions. So when in doubt, if all else fails, if factoring isn't working, if square root property isn't working, if completing the square isn't working, if all else fails, you can always fall back on the quadratic formula to solve any quadratic equation. So remember, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that will be very important to remember, because like I said, this is a fallback. Worst case, you can always use the quadratic formula. So this would be very, very important to memorize. Negative b plus minus square root of b squared minus 4ac over 2a. All right, when we have it in this form, we got our a, we got our b, and we got our c. And just a little, while I'm thinking of it, just a quick note. Be careful with this negative b, because sometimes, especially when you're subtracting a b, like maybe it's minus 3x, be careful when you're inputting that, because you'd be taking a minus 3x, or sorry, a minus 3, which would become positive, right? But the two lines come together, make a plus. So if you're subtracting your bx, be careful when you input that. You'd have a minus, so it would become positive. So just be mindful of things like that. Let's take a look at an example. And I'll rewrite it out here so we have it. So we have x equals negative b plus minus the square root b squared minus 4ac all over 2a. All right, so for our example, let's do 2x squared equals negative 10x minus 2. All right, so if you're looking at this, well, our first problem is we've got stuff on the left, we got stuff on the right. We're nowhere near in general form. So let's start working towards getting it that way. So let's get that 10x moved over. So we have 2x squared plus 10x equals negative 2, and then add the 2. Now we're in business. 2x squared plus 10x plus 2 equals 0. So now Now we are in general form. So now we can start working towards inputting into our quadratic equation. So we have our A, we have our B, and we have our C. So let's get things inputted here. So we have, well, so you can still see it. All right, so we have x equals negative b, so our b is 10. So we'll be at negative 10 plus minus. And then we have b squared. So we have 10 squared minus 4 times a, which is 2, times c, which is 2. And that is over 2 times a, which is 2. Okay. So let's simplify that a bit. So we have negative 10 plus or minus the square root of, we have 10 squared is 100, minus 4 times 2 is 8, times 2 is 16. 100 minus 16 over 4. And keep simplifying down. So this is equal to negative 10 plus or minus. So we have the square root. 100 minus 16 is 84 over 4. And let's take in, we will simplify this a little bit. So if you recall how we did that, so we're going to simplify square root of 84. So what do we have for factors of 84? We know that's 2 times 42. And 42, that's 2 times 21. And then remember, as soon as we have a duplicate on this left side of the tree here, that's what goes on the outside. And then under the square root is whatever the last number was that we simplified down to. So the 21 goes under the square root. So 2 times square root of 21 is equal to, if you put in the calculator, same thing as the square root of 84. So we just simplified that is all. So let's input that. So now we are at x equals, we still have the negative 10 here, plus minus, and now we simplified it down to 2 square root of 21 all over 4. And then this could be simplified a little. We have negative 10, 2, and 4. So let's simplify, let's divide by 2. We can simplify this. So we have x equals negative 10 divided by 2 is negative 5 plus minus, and then that gets rid of that 2 there. 2 divided by 2 is just 1, so we can get rid of that. So we just have square root of 21, and then 4 divided by 2 is 2. And of course, if asked, we could get a decimal approximation and solve it out if we wanted. We have 2 solutions, of course, but we'll leave it in this form. So we have x equal to negative 5 plus or minus the square root of 21 divided by 2 as our final answer. All right, let's do another example using the quadratic. So we have 4x squared plus 12x plus 9 equals 0. So we're already in general form. So that's good. Ax squared plus bx plus c equals 0. So let's identify, we have our a, we have our b, and we have our c. So now let's input into the quadratic. Again, the negative b plus minus square root b squared minus 4ac over 2a. So we have b is 12, so we'll have negative 12 plus minus, and we have 12 squared minus 4 times 4 times 9 over 2 times 4. All right, so I have x equals, so we have negative 12 plus minus, so what do we have going on under the radical? We have 12 squared, which is 144, minus 4 times 4, that's 16, times 9 is also 144, divided by 8. So we end up with negative 12 plus minus, so we have the square root of 0 over 8, and square root of 0 is just 0, so that's not doing anything for us. So we can take that out altogether in this case. So we're just left with negative 12 over 8. So this one only had one solution. And that could be, if you want to, you can simplify that down. If we divide each part by 4, so we'd end up with 3 over 2, so either or. So that is our final solution for that one. And the last topic we're going to look at in this lesson is a specific part of the quadratic formula. And it'll kind of tie into like the last one we just did, how it came to be that one only had one solution. So it'd be kind of a trick using a part of the quadratic formula. So let's get it written out. Again, get this committed to memory. Negative b plus minus b squared minus 4ac over 2a. And the part that we are looking at here is, we're looking at this part right here. This b squared minus 4ac, that is going to be what's called the discriminant. All right. So b squared minus 4ac, that's called the discriminant. Again, be mindful, don't worry about the square root. It's what's inside the square root, right? So it's just the b squared minus 4ac, the discriminant of the general form equation for a quadratic ax squared plus bx plus c equals 0. And often the discriminant is just given by the symbol, by uppercase D. And we can use the discriminant to determine the number and type of solutions of a quadratic equation. So let's just summarize. Let's summarize this idea here. So that's so we have our discriminant, d equals b squared minus 4ac. Now, d, the discriminant, is greater than 0. All right, that's put a line through. So, that's a 0. If it's greater than 0, there are two distinct real solutions. All right. So the discriminant is greater than 0. There's two distinct real solutions. And if it helps to visualize it, if we wanted to see that on a graph, we might have something like maybe we have something like that. So we have two distinct solutions for what x equals. X equals two distinct solutions. Now, if d, the discriminant, is equal to 0, like we saw in the example we just did, we had 144 minus 144 under the square root. So when the discriminant is equal to 0, as we saw, there is exactly one real solution. So that might be something like, so that one, if we imagine it only touches the x-axis once. There's one x-intercept. There is one real solution. And then all that's left is if d, the discriminant, is less than 0, there is no real solution. So that might look something like, so maybe we just have something like that. So in this case, it doesn't cross, it doesn't hit the x-axis at all, so there's no x-intercepts, so there's no real solution when the discriminant is less than 0. So now knowing that, let's just take a look at a couple examples. All right, so we have when the discriminant is greater than, equal to, or less than 0. All right, just so we can see it in practice. So if we had 2x squared equals 5x minus 7, well, let's get it in. First thing we want to do is let's see it in that general form. So let's subtract the 5x over. And then add the 7. Okay, so now we have it in general form. And then we can identify our A, our B, and our C. And we said the discriminant, that's the part under the square root in the quadratic formula, b squared minus 4ac. So in this case, the discriminant is equal to b, which is negative 5, squared minus 4 times 2 times 7. So negative 5 squared, so that's 25. And then 4 times 2 is 8, times 7 is 56. So the discriminant is equal to 25 minus 56 will be negative 31. So, since our discriminant is less than 0, this would have no real solution. And just so you guys can see it, if you were to graph this one, it would look something like that. So obviously we're up here, we're nowhere near the x-axis. So there's no x-intercepts, there's no real solution for this one. And let's try one more. How about 2x squared plus 11x minus 6 equals 0? So we're already in general form. We have our A, our B, and our C. So we have the discriminant is equal to B squared. So we have 11 squared minus 4 times A times C, negative 6. So we end up with 11 squared, that's 121, minus 4 times 2 is 8, times negative 6 is negative 48. So minus a negative 48, which would just be plus 48. So 121 plus 48, which gets us 121 plus 48 is 169. So obviously we are greater than 0 in this case, and when the discriminant is greater than 0, that means we have two distinct solutions. And again, if you were to graph this one, it would look something like that, roughly. So we have two spots where it crosses. We have two distinct solutions for what x equals. All right. So we've seen between this and the previous video, so now we've seen 4 methods that we can use for solving quadratic equations. We have factoring, we have the square root property, we have completing the square, which leads into the square root property, and at the very least, we have the quadratic formula. So between those, now we have the tools needed to solve any quadratic equation that we are given. So that'll do it for this lesson. Hope it was helpful, and thank you, as always, for watching. Be sure to check out the channel for more algebra lessons as they come up.